according to their characteristics. So from this study, we observe that strontium Kd and sorption D and strontium desorption Kd values are not varying much. The value and the signs are almost similar. So from this, we can conclude that strontium sorption or desorption is not dependent on the factors of soils or groundwater parameters. Rather, it is dependent on the speciation of strontium taking place on soil surface, and that's why it is mobile in the Fukushima environment. So if speciation is not strong with the soil surface, then strontium species can further migrate to the local environment. So in case of cesium and strontium sorption, if it is taking ion exchange process, then in case of uranium, we observe that complexation is also playing a role in uranium sorption. The table here, which I am showing, is sorption, desorption, and its correlation with soil characteristics. I don't want to go much detail because there is less time with me. So soil characteristics are not the single entities which are taking part in sorption and desorption process. However, there are other factors like presence of ligand and minerals and composition of clay, which are playing role in sorption and desorption processes of these metals. For example, we observe that calcium carbonate and iron oxide and organic matter, they are also playing role in these processes. All these characteristics can define the interaction of metal ion with soil in quantitative way, but not in qualitative way. So in order to have thorough understanding of the mechanism of sorption and desorption processes, one has to carry out the spectroscopic studies, and one has to separate minerals to check the presence of different parameters such as temperature, pH, and ionic strength, and how they are affecting these processes. So these are my publications related to this topic. I'm just a beginner in this field, but I'm still trying my best. So I would like to summarize my talk. Determination of distribution coefficients of cesium, strontium, and uranium in Fukushima soils helps to understand the behavior of these radionuclides in environment, and it is important from locals' point of view. Sorption of cesium is enhanced due to presence of selective minerals than strontium. Hence, strontium binding is weaker on soils compared to cesium. Sorption of cesium and strontium takes place through ion exchange process, whereas uranium complexation was also observed. Correlation with sorption and desorption studies corroborates the presence of high radiocesium activity in Fukushima environment than cesium and uranium. So why cesium was radiocesium was mainly observed in these soils, and why not radiostrontium? So one of the reason is lying here. The information of species sorbed on mineral surface besides the migration of cesium, strontium, and uranium in the present study. In short, strontium was found to be mobile than uranium, which is still mobile than cesium. I would like to show some photographs that before 10 years, like when Fukushima nuclear accident happened. So at that time, the wall, which is protecting from seashore activities, it was broken and it was damaged, and that's why water entered into the local area, residential area. But after 10 years, the wall is again built up, and it is now 10-meter high, and city is welcoming all residents as well as tourists, and city is ready for its day-to-day life. This is where Fukushima reactor we can see. So finally, I would like to acknowledge my co-authors, Dr. S.K. Sahu, for his guidance in this topic, Dr. Kawashi and Omori and Sorimachi for collection of samples and discussion point to point, Then Mr. Arai for helping me in laboratory work and for training also. And Dr. Auno, he's our team leader. So he's also guiding in research activities. These are scenic beauties from Japan. This is Mount Fuji. So thank you for your kind attention. And this is cherry blossom, which is now spring season started in Japan. So I would like to welcome all for Japan sightseeing with these two scenic beauties. Thank you very much.
Yeah, thank you, Dr. Shari. A very fascinating talk and very interesting aspect you have discussed. And I mean, the experiment is exhaustive and very interesting results are seen. And you have touched upon some of the basics. I think that is very useful for the young students, master's student to understand the basics of distribution coefficient. I think you have touched upon well. And then I think the experiments have a implication for this nuclear waste and all those things, which is a very important aspect. So I think it's really highly educative talk, and I welcome question. Anybody has any question? Just raise your hand, and then mic can be given to you.
Sir, Chandrachudan sir is there with us.
Okay.
Sir, you can unmute yourself.
I can see some questions also here. If Dr.
Chandrachudan sir is there with us, sir.
There, then
so you can unmute and ask the questions.
Yeah,
yes, I am here. It was an excellent presentation by Dr. Sarayuka sir.
Thank you.
Yeah, because you have collected enormous and very useful data relevant to the contamination owing to the accident. My question is, was there any baseline data available on these radioactive elements, to enable comparison pre-accident and post-accident scenario? That is the question which I raised.
Yes, considering the concentration of nuclides, if we are asking just concentration, then there are some data present. And if you are asking from KD point of view, then few data, because KD is highly site-specific study, so value can vary from place to place and time to time.
I asked this question basically because there are about 9 nuclear reactors along the western coast of Japan. So there can be, during the course or minor incidents, there can be contamination carried out and on the soil, even which cannot be directly attributable to the Fukushima. So we had in our Kudangulam project, we had an extensive baseline study done even before the reactor became critical. So that's why that will enable a proper reasonable comparison attributable to the specific incidents. That is.
Yes, we have.
And second thing is your observation about the mobility of strontium is very interesting. When cesium is supposed to be more water soluble.
Cesium, sorry.
Solubility of cesium is more in water compared to strontium. So, but your study have found that strontium is more mobile and cesium is held in the matrices.
Yes, because there are some clay minerals which are tightly bound with cesium, and that's why it is not coming out or leaching.
It gets absorbed in the clay matter. Okay.
Yes.
Okay.
Yeah. Cesium is sometimes very particle reactive. So that goes into the matrix of this, and as you see the fine clay material, the clay material has a more tendency to absorb more of the cesium.
Yeah, that's specific adsorption characteristic. Thank you very much.
Yes.
Yeah, just a comment. I mean, I believe that this baseline data should be there. I mean, maybe it is not published, but it will be there in some reports, because whenever you have a nuclear plants and coming up, they do all this EIA assessment and everything. And during that period, they do rigorous this soil sampling and other stuff. In fact, they go for aerosol, atmospheric pollution and everything. So there is a baseline data, of course, I believe there will be.
Yeah.
Yes, it is available, and we are also working on isotope ratio. So we are always comparing pre-accident data with post-accident data. But this part, this topic is not with from that perspective. So that's why I didn't include that.
That was a very interesting talk, and all the best to you. You are doing a great work there. Thank you.
Thank you. Thank you very much, sir.
Yeah.
Thank you
More
very
questions?
much, Chandrasekharan sir. Chandrachudan sir, it is our honor to that you have joined with us. Chandra sir is National President of ISAS, Mumbai, and he is a former director of BAC.
No. I am not the
It
director of
is
BARC.
really
I was associated with the baseline studies in Kudankulam projects. So
yes, sir.
the speaker today is also a PhD from BRC. I found her talk very interesting and highly relevant to the nuclear energy program, which is supposed to be by all means a green energy program. Thank you very much. Thank you very much.
Thank you, sir.
Thank you very much.
Thank you,
you,
Chairman.
sir.
Thank you very much.
Thank you, sir. Thank you. More questions? No more questions? Well, I have few, maybe not questions, but some comments or remarks maybe.
Yes.
Not related to your project. Means I'm just curious whether is there any study because you see the Fukushima nuclear reactor is at the coastal belt. So the contamination which you are seeing in the soil, at some stage this may be getting transported towards the ocean.
Yes.
In your oceanographer, I have some curiosity. Did you see that these soil which are getting transported towards the ocean, did you see any enhancement in the strontium or cesium budget, particularly in the coastal belt? Is there any study?
Yes, there are studies. And specifically, if we want to say, then there are studies on sediments also. But we are working on soils or terrestrial environment. That's why.
Yeah, the implication is enormous because if it goes to the ocean and then the ocean ecosystem is getting perturbed, because these are some of the these are not as a nutrient, rather it is a toxicant, because the biology get affected a lot. So I think such kind of reactor which are on the coastal, they have they can contribute to the ecosystem and can perturb a lot. So that kind of work is actually important. Now, another thing which just you mentioned, that strontium is not the desorption and desorption of strontium is not dependent on the soil characteristic. Rather, it is a speciation which is actually creating the distribution. What exactly this speciation means? I was just curious how.
So, as you said that there are some clay minerals and which are selective for cesium. There are some clay minerals which are selective for strontium also, but such clay minerals are not present in these soils. And if such minerals are not present, then the bond which is formed with the strontium species is not very strong. So here mostly I have not carried out isotope studies and speciation studies in these soils, but my previous experience from that I can say generally cesium and strontium, they will form ionic type of species, and if these are not strongly bound with the surface, then metal can be easily washed away.
Okay.
So species, from that point of view, I'm saying species. Yes.
Yeah. Okay. Thank you very much. And I must thank the speaker. And now over to the organizers, to Pooja.
Yes, I'm also thankful to organizing committee for giving me this opportunity. Thank you very much. And I would like to mention Dr. Vijaya Lakshmi Adya. She contacted me for this talk and regarding conference information. So I'm thankful to her also. Thank you very much, Dr. Ashwinder, again. Thank you
Yeah,
all.
thank you.
Thank you. Thank you very much, ma'am. Now I invite Dr. Sushmita Mandavkane, ma'am, convener ICNHTCS 2022, to read the citations. Respected Dr. Sharayu Kasar, Senior Researcher, National Institute of Quantum Science and Technology, Chiba, Japan. Respected Dr. Ashwini Kumar Jha, Senior Scientist, CSIR National Institute of Oceanography, Goa. I, Dr. Sushmita Mandavane, convener of ICNHTCS 2022, place my deepest regard for accepting our invitation to honor this conference with your presence and enlightening the participants with your deep knowledge. Let me formally place my gratitude to both the dignitaries by virtually presenting their appreciation certificates. I proudly present the Certificate of Appreciation to Dr. Sharayu Kasar for delivering an invited talk during this technical session virtually.
Thank you.
Also,
Thank you very much.
Also, I proudly present the Certificate of Appreciation to Dr. Ashwini Kumar Jha for chairing the technical session of the International Conference on New Horizons and Trends in Chemical Sciences, organized by Department of Chemistry, Dada Ramchand Bakru Sindhu Mahavidyalaya, Nagpur, in association with the Indian Society of Analytical Scientists, Nagpur chapter. Thank you.
Thank you very much. My honor. Thank you.
थैंक यू अश्विनी सर.
Yeah, thank you, Chandrasekhar.
हाँ, कैसे हैं सर आप?
बस फर्स्ट क्लास में.
थैंक यू सर. थैंक यू वेरी मच.
Yeah,
थैंक यू शरयू मैडम.
Thank you very much.
Thank you.
Thank you, Sharayu.
Thank
And
you.
thank you, Ashwini Kumar sir.
Thank you.
Thank you, ma'am. Now I propose a formal vote of thanks for the session. Let me take a privilege to express my gratitude to Chairperson Dr. Ashwini Kumar Jha for beautifully summarizing today's session. I cordially thanks Dr. Sharayu Kasar ma'am, resource person of today's session. In her talk, she explained well about distribution coefficient of cesium, strontium, and uranium in soil water system around FNDPS. She quoted that unsorbed strontium could migrate further than unsorbed cesium and uranium under some experimental conditions. I extend my gratitude to all the participants of the session for patiently listening and for their active participation. Thank you all. I announce the end of technical session. All the participants of oral presentation are requested to join at 2:30 p.m. sharp at their respective links. The links are already provided to them, and they are requested to be ready with their presentations. Thank you all.
Thank you.
चलो